Lecture 16 covers section 6.1. At the end of today's lecture, you should be able to determine the normal and shear stress generated within an axially loaded member, and where the maxima of these stresses occur. You should also be able to determine if an axially loaded member is in compression or tension. Lastly, you should be able to determine the bearing stress within an axially loaded member. For us to begin, we want to determine the effect of our external and/or reactionary forces that are acting on individual components, such that we can determine the behavior of the material. Now, internal forces, which counteract our external forces, lead to deformation of our material, and deformation leads to movement, wear, and potentially failure of our mechanical part. After we determine the amount of stress an object is subjected to due to the internal reactionary forces being generated, we can properly size or select the material such that we can prevent failure. Now let us talk about an axially loaded member. Axial loading occurs when a member is subjected to a system of two or more collinear forces, and these forces are going to act along the axis of said member. That is, we can have F1 and F2 pushing inward on a rod. Now, if we cut this member anywhere along its length, we can see, for this member to be in equilibrium, that an internal reactionary force R has to develop. R is going to counteract or balance our externally applied force. That is, if we cut a rod in the middle, we'd have R opposing F1 and R opposing F2. Now, R can either resist a member being compressed, or it can resist a member being stretched. Compressive forces tend to decrease the length of our member, while tensile forces tend to increase the length of our member. Now, this internal reactionary force is going to result in the generation of a stress, and we can define our average normal stress, sigma, as this internal reactionary force per the cross-sectional area of our member. We note that sigma has units of pascals, or force per unit area. Now, R in this instance is going to be taken normal to the cross-sectional area, and we'll also treat R as a distributed load, acting over this cross-sectional area. By convention, if our stress is positive, we say our member is under tension, and if our stress is negative, we say our member is under compression. We'll just look at an example of this. Say we have a steel chain link with geometry as shown below. We want to determine the average normal stress existing in a horizontal member of the chain. To do such, we'll cut our chain, and we'll look at the internal reactionary forces. That is, if we cut the chain down the middle, we'd recognize we'd have a 750 kilonewton force applied to the left, and two 375 kilonewton internal reactionary forces existing. Thus, our average normal stress in a horizontal member of our chain is defined as follows. Sigma average is equal to R per A, where our internal reactionary force is 375 kilonewtons. Our area is pi d squared per 4. Thus, we'd have 4 times 375 kilonewtons per pi times the quantity 0.0127 meters squared. Or the average normal stress in a horizontal member is 2.96 gigapascals.